Hello guys, welcome back to my YouTube channel, Mr. Electric DIY. In this video, I'm going to talk about the basics of electromagnetic relay and what at all does electromagnetic relay mean. In simple terms, this is basic tutorials on how to use electromagnetic relay. Before we get started, I want us to look at a short description on the coil and the socket. This part of electromagnetic relay I'm holding right now, this is the socket or the base of a relay. This is the socket or the base. Now you could see that we have 7 amps of current here and 250 volts. The 7 amps you see here is the maximum current that the base can carry or the socket can carry, and the 250 volts is the maximum voltage that the base can carry. We also have a description on the coil. This is the coil. Clearly you could see that we have 230 volts AC, 50 to 60 hertz frequency. That's the hertz, the frequency. And down here we have 5 amps and 250 volts AC. This 250 volts AC also means maximum voltage that the coil can carry. That's the maximum voltage. And the 230 here, if your voltage is either 230 or 240 or even 250, it will still energize the coil inside this component. We have a coil inside. That is why we call it a coil. This is Schneider type. We have a coil inside this part that I'm holding. That's why we call it the coil of a relay. And we have the coil and the contact. This is the contact and this is the coil. And the same way, you could see that we have a whole diagram here, a whole drawing of how to use this electromagnetic relay. Now it is the same drawing that I've drew on this paper, and maybe you might not see it well, so I've drew it to explain all the things you need to know or the things you need to do before you use this type of relay. So don't be worried if you are seeing another drawing here. It's the same way. This is the coil, as I said earlier, and this is the socket or the base. The only thing you will see on the base or this socket is numbers, and this is the same numbers we have here. This is the same numbers we have here. And in this video, we are only going to focus on the numbers in the bracket. You could see that you have numbers in the bracket and others to not in the bracket, and we are going to focus on the numbers in the bracket. This is Schneider type of electromagnetic relay. Schneider Electric. As I was saying, the only thing you will see on the base is numbers, and it is the same numbers that you're supposed to look at before you'll be able to use the base. This drawing represents a coil. This is the coil, and inside this component we have contacts and also the coil itself. Now we have 14 and 13. These are the live and the neutral. If you want to energize this coil, you have to supply it with live and neutral cable before it will be energized. That is the maximum is the 250. You have it here, the voltage 250. So we have the A2, and the A2 is number 14, and we have A1, and A1 is number 13. You have it here. This is the number 14. You have 14 top right here and the 13. These are the supply voltage where you are supposed to connect your live and your neutral, the supply. And when you are using magnetic contactor, your A2 is the neutral and A1 is the live, and the same way as electromagnetic relay. Your A2 is the neutral and your A1 is the live. That is the 13 and the 14. Now we are done with connecting the coil. If I supply it with neutral and live, it will energize right now as I'm talking. It will energize, and when it energizes, this contact, the normally close will open and the normally open will also close. We have number 9 here. This is number 9 and this is number 12, and these terminals you see here is the common. Number 9 is common and number 12 is common. In case you want to use number 5, this is number 5, and just now number 5 is normally open and number 1 is normally closed. the 9 is directly linking to number 1. And the moment the coil receives its right voltage, the close will open and the open will be closed. And the same thing happens to this this contact. This is number 12. If you want to use the number this contact, either number 8 or number 4. If you want to use number 8, then you energize the coil. Then the number 12 is linking directly to number 4. So the linking here, it will break. Then this bar, this number 12, the bar will come and link to number 8. And in this video, we are practically going to energize it to see how this electromagnetic relay works. Now, I will just remove it for you to see how it works. I've removed it. Let me also remove this one to have a clear view. I'll remove this plastic 13 and the 14. We have it here. This is number 13. I don't know if you see it. This is 13 and this is 14. The moment I connect my live and neutral, this is the coil. To generate a magnetic field, and it's the same field that is going to attract this terminal we see here. Now you could see that we have a flat bar over here. There's a bar. Yes. The moment I supply it with the right voltage, this coil will generate magnetic field, and this is the field that is going to pull this to serve as a magnet, a normal magnet. But that magnet is made from electricity. That's why you call it electromagnetic relay. Now, the moment the bar here magnetized, to try and pull this, there's a plate under this, a copper plate. Have that copper plate here. So just this bar you see down here, this plate you see down here, it will serve as a magnet. And it's going to pull this. There's a plate under this plastic you see here. There's a plate, and the moment it pulls it, now this contact, this is the common, this is the common, and it is linking directly to this terminal. So just now this terminal is at normally closed position. The moment it pulls it, the magnetic field generated by the coil pulls it, then to open and come and link to the downside. Just now on it has moved from its resting position. That's the normally closed to this terminal. So just now it has opened this side, and it is linking directly to this side. And when we say normally closed simply means the resting position of a terminal. So this bar is linking directly to this terminal we have here, this terminal. Now it is at normally closed position. So the moment I energize the coil, it will move from this section to this section, to move from here to here. So the normally closed simply means in the resting position of a contact, just as it's resting. And if I say normally open, so it also means the resting position of a contact. So this terminal we have here, this terminal, the one that I'm pointing with my hand, is at normally open section. So just now that's the resting position. The moment I energize the coil, then the bar will move. This bar we have here will attract. There's a plate under this plastic to just attract that plate, and then it will be like this. It will come and link to this normally open section or normally open terminal. Now I will supply it with a 230 voltage to know how it works. What I have to do is connect my live and neutral cable. I have the red cable here as my live, and the live is number 13. That is the A1. I have A1 here. This is number 13. Just connect it. The black cable as my neutral. The neutral is also connected to number 14. I have 14 here. I also have my breaker here, so I'll just connect it to it. We have successfully connected our live and neutral. So we're going to turn on the switch for you to see how the normally closed and the normally open contacts changes position. Now, The moment I've connected the neutral and the live to the coil. The moment I turn on the switch, this number 9 is linking directly to number 1, so it is at normally closed position. The moment I turn on the switch, it will just this 9 linking to 1 this bar will break and come and link to number 5, and number 1 will turn to normally open, and number 5 will turn to normally close. That is when the coil achieve its energization. And the number 12 is also linking directly to number 4. So the moment I turn on the switch, this bar will break and come and link to number 8, and number 8 will turn to normally close, and number 4 will turn to normally open. That's how a relay works. Yes, the indication diode has turned on. Normally close has turned to normally open, and the normally open has turned to normally close. I turn off the switch. Just look at it very well. Yes, that's the way it works. You could hear the sound. And this is the spring helping you to close and open. So the moment the coil generates the magnetic field, it will just pull the plates we have down here. Just pull it. Now, the only thing you have to also take note is that if you want to use this is normally open. Then to use this magnetic relay without the energization, then you have to use the normally closed terminals. And if you want to use it after it has energized, then you have to use the normally open, because when it's energized, the close will tend to open and the open will tend to close. Now, let's perform a small experiment also with a multimeter. I have my multimeter here. I'll just tune it to continuity. Yes, that's the B pin. Now, I'm going to check number 9 and number 1. As I said, number 9 and number 12 is the common terminals, number 9 and number 12. So if you want to use this 4 and 8, you have to link a live to your number 12. That is when you want to use either 4 or 8. You have to link a live wire to number 12. If you don't want to use the number 12 and you want to use number 9, this is a common terminal. You have to link a live conductor or a live wire to number 9 before you'll be able to use this contact in the same way to this contact. And you can directly link it from, that is the T18 to the number 9 or the T18 to number 12. It will still work. You can also pick it a live wire from your breaker and directly to number 9 or number 12 if you want it that way. If you don't want that way, just link here to the common. It will still work. Now we are going to check number 9 and number 1. They are directly linking. So I have the multimeter here. You just go right ahead and check it. You have number 9 here, and this is number 9 and this is number 1. They are linking. I've turned off the switch. So just now the normally close is at its resting position and normally open to is at. But we are going to check it to confirm whether it is true or not. This is number 9 and down here is number 1. Yes, it's working. Now let me turn on the switch and we check it again. I've turned it on. You can see the indication diode here. Number 1. Just now, number 1 is not working, meaning it has turned to normal open. Now, the same number 9, you can see that we have number 9 here, this linking to number 1, that is normally closed, and we have number 9 to number 5. Just now, this bar has shifted to number 5, and it has break the number 1. So we are going to check the number 5 to confirm whether it is true or not. This is number 9. We have number 5 here. Yes. The moment the coil energizes, then the normal close will turn to normal open, and normal open or tend to normally close. So just now the normal open contact has turned to normally close, and the normally close contact has turned to normal open. If you find this video helpful, make sure to like and subscribe. And if you have any question, make sure to ask me in the comment section. I'll be there to answer all your questions. Thanks for watching. Goodbye.